Hello, welcome to this video. This is 2-7 and we are going to talk about the product rule. I've taught you basic derivative functions such as the power rule and the derivatives of the other four important functions, and today we're going to go ahead and encounter what if I have two functions multiplying together. Alright, so right away go ahead and recall if f of x is equal to 5 times g of x minus 3, then f prime of x is equal to 5 times g prime of x. And that is just the constant or the scalar multiple rule of a derivative, right? The multiplier just stays and we take the derivative of the function. Now the derivative of negative 3 is 0, so that falls off. But what if I was multiplying here and it's not a scalar multiple? What if it's not just a number times a function? What if I have a function times a function? How can we find f prime of x? Now, one common idea, and this just pops into people's heads, is, hey, I got to take the derivative of each of them. G prime times h prime. Well, let's go ahead and look at a basic function, and then go ahead and see if this in fact works. So here I have f of x, and f of x is equal to 3x squared minus 2 times g of x, which, times the second function, which is 4x plus 7, and we're asked to find f prime of x. So using this logic right here for method number 1, that f prime is g prime times h prime, well, the first function, right, the derivative of the first one is 6x. And the derivative of the second function is just 4. So here we have a derivative of 24x. Okay, so that's method number 1. I'm just going to take the derivative of each of them and multiply. Method number 2 says, hey, first, why don't you just go ahead and distribute? Because isn't this how we found the derivatives up until this point? So if I distribute 3x squared times 4x, we get 12x cubed. 3x squared times 7 gives me 21x squared. Negative 8x minus 14. So there's our function, right? If I distribute that out, and then now I'm just going to go ahead and use the power rule. Well, doesn't this become 36x squared plus 42x minus 8? Checking my notes. Yes, that's right. Now, are those the same thing? Could they be correct? Could both be correct? Well, no. I mean, there's one certain method, okay, that works, okay, and the first one's not it. Method number 2 was correct, but there's also a problem with that. I don't always have polynomials, right? We deal with other functions such as sine, cosine, okay? So we're going to go ahead and fill that in because not all functions are polynomials. So, the conundrum that we are at, it is very useful and convenient to have a rule that can be used when we are working with products. So if I have two functions multiplying with each other, I'm going to go ahead and use what is called the product rule. The product rule, and that works when you have one function multiplying times another function. Okay, so if this is the case, if f of x is g of x times h of x, then I'm going to go ahead and take the derivative of the first function, so g prime of x, and I'm going to multiply it times the second, times h of x. And then I'm going to go ahead and add the derivative of the second function, h prime of x, and multiply times the first function, times g of x. So you take a derivative of the first one, multiply it times the second, and then take the derivative of the second one and multiply it times the first one. In calculus, we can only take the derivative of one function at a time. We only take one derivative at a time. We don't take both. Okay, and then here they say we can express the product rule in terms of u and v. This is going to be u prime times v plus v prime times u. And another method I like writing down, go ahead and write this down. fs prime, the derivative of f and s. And in fact, I like color coding this because this kind of helps us. F times s. So the derivative of f times s, where they are functions, is f prime, derivative of the first one, times the second, plus the derivative of the second, s prime, times the first. And that is the product rule. That's the product rule. This is one of those things that you want to put on a flashcard that you want to go ahead and memorize. So make a little flashcard that says product rule. Product rule. And you would want to have something like this on the backside, or something like that, what we wrote up there. Okay, just to go ahead and quiz yourself. All right, let's go ahead and apply this. So example number two. If f of x is equal to x squared times sine of x. Now the first thing that you need to be really good at is identifying that you have two functions. I have one function here, x squared, times another function here. This is product rule. Now you don't always see multiplication, or you don't always see parentheses. So understanding that if I have multiple x's, okay, if this is not a polynomial, if I can't combine stuff, right, multiple inputs, then these are two different functions. Okay? So I'm going to go ahead and I'm going to use the product rule. And if you get pretty good at this, you can just go straight into the product rule. But if not, something that you can do is you can say, okay, my first function is x squared, and the derivative of that is 2x. So you're identifying your first function, the derivative of that function is 2x. And then you can say, okay, my second function is sine of x, and the derivative, s prime, is cosine of x. So you already have the information laid out, and then you can just go ahead and put it into a template. So f prime of x, the derivative of the first function, that's 2x, times the second function, that's sine of x, plus the derivative of the second function, well, that's cosine of x, times the first function, which is x squared. Okay, and if you want, you could go ahead and put that x squared in front, which is generally actually how it's seen. It would be x squared cosine of x. Okay, so that is the product rule. That's the product rule. We just took the derivative of two functions that are multiplying. We use the product rule. Example 3. G of x is equal to x cubed natural log of x. Hey, is this product rule? Well, I have one function here, and then I have another x here, another function, so they're next to each other. That's multiplication. We got to go ahead and take the derivative. So again, I'm just going to identify my first function. F is x cubed. F prime is 3x squared. S is the natural log of x, and the derivative of that is 1 over x. Okay, so now that I've worked through that off to the side, I can just go ahead and say, okay, g prime of x is equal to 3x squared times the natural log of x plus the derivative of the second, 1 over x, times x cubed. And of course, we can go ahead and clean this up. 3x squared natural log of x plus x to the power of 2. Okay, so there is our function. Pretty straightforward, right? Not too difficult or complicated. Okay. All right, now let's go ahead and give you multiple terms. So notice I have x minus 2e to the x cosine of x. So I'm going to go ahead and I want you to see where product rule applies. E to the x times cosine of x. I have two functions multiplying times each other. So I'm going to go ahead and say, okay, hey, the first function is e to the x, and the derivative of e to the x is e to the x. My second function is cosine of x, and the derivative of cosine of x is negative sine x. Okay, so now let's go ahead and let's apply our derivative. So f prime of x is equal to the derivative of x, That's just 1, right? The coefficient of that is 1. It's 1. Okay? Minus 2. Do you guys see this multiplier? That minus 2. You're going to leave that out. You're going to multiply now times my product rule. Okay, I'm going to go ahead and multiply these. So the derivative of e to the x is e to the x cosine of x. Okay, plus the derivative of the second, which is negative sine of x, which I'll put in parentheses just to keep that negative separated, times the first function, times e to the x. Okay? And we can go ahead and kind of clean this up. So this is 1 minus 2e to the x cosine of x. And we have a negative 2 times a negative, which gives us a positive 2. And I'll just move that e to the x to the front. Sine of x. Okay? There is our derivative. There's our derivative. And if you wanted to, also, you could factor out that 2e to the x. You see how they both have the 2e to the x? So 1, I'll take out a negative 2e to the x. So this would be cosine of x. And then because I took out the negative, that sine of x is back to being negative. Okay, so equivalent. All right, example number 5. Here I have h of x equals cosine of x times the square root of x. Find h prime. Go ahead, pause the video. I want you to try this one. Go ahead, give this one a go. Okay, hopefully you went ahead and gave this a try. Cosine of x, that's your first function. Square root of x is your second function. So my first function, cosine of x, the first function with the derivative is negative sine of x. Okay, my second function, that's x to the power of 1/2. And so the derivative of that would be 1/2 x to the power of negative 1/2. Okay, so here is h prime. Derivative of the first, so negative sine of x times the second times square root of x plus the derivative of the second, which is 1/2 x to the power of negative 1/2 times the first, which is cosine of x. Okay, and here I'm going to go ahead and I'm just going to clean some stuff up. So negative square root of x sine of x looks like plus cosine of x over 2 square root of x. And I believe that is correct. Yep, so I got my notes. So there you go. Okay. All right. So that is with functions. That's in analytic form. But on the AP test, they also love to test us in the form of tables. So we're going to go ahead and see how that applies here. They say selected values of the twice differentiable function f of x are given in the table above along with f prime of x and f double prime of x. Use this information to find the following. They say, example 6, h of x is equal to 4x f of x, and we want to find h prime of 1. Okay, well, again, my first function here is x, or 4x, and then the second function is f of x. Okay, so h prime of x, this is going to be equal to 4 times derivative of the first, that's just 1, times the second, so we really just have f of x there, plus the derivative of the second, f prime of x, times the first, which is an x. Okay, and all of that is times 4. So there is my function, and I'm just going to go ahead and directly now plug in 1. H prime of 1. Okay, so let's fill in. Wherever there's an x, we're going to fill in 1. So f of 1 plus, I guess 1 times f prime of 1, which we don't really need to write, but I will do it there. I'll leave that there. Okay, so now it looks like I just need f of 1 and f prime of 1. So I'm going to go to my data table. I'm going to identify my independent variable 1 and say, okay, f of 1 is 6 and f prime of 1 is negative 2. So it looks like we have 4 times 6 plus negative 2, which looks like 4 times 4, which is 16. Not too bad. It's the same thing, it's just we're also using a table to find the information. Okay, example number 7. K of x is equal to 3 sine of x f of x. Again, this multiplier, that's just going to hang out front, okay? And then my second function is f of x. Okay, so they say find k of 0. Hey, that's just a function. Check this out. Do they want a derivative here at all? No, they just want k of 0. K of 0. Well, that's 3 times sine of 0 times f of 0. Okay, so that's 3 times sine of 0, which maybe you know that that is 0, times f of 0. Okay, well, f of 0 is negative 4. Negative 4. Okay, and so all of this just gives me 0. So that's 0. Okay, what if they wanted k prime, though? K prime would be a different problem, right? So just pay attention to notation, because that's important. All right, example 8. Example 8. Whoo! Look at this monster. Wow, there's a lot here. So I'm just going to break this down. P of x is equal to e to the power of x times f of x. Hey, I'm going to have to do product rule here. That's product rule for sure. Minus f prime of x times x squared minus x. Oh my gosh. Wow, I'm going to have to do product rule again, a second time, and pay attention to that negative. Okay, so, and they want p prime of 5. So the first task, the first endeavor that we're going to have to do is calculate p prime of x. So the derivative of the first, e to the x times the second, f of x, plus the derivative of the second, f prime of x, times the first, e to the x. Okay, so there's that first piece. All right, minus, I'm going to put a big fat parenthesis whenever I have that subtraction. Big parenthesis. Okay, derivative of the first. Well, that's f double prime of x. I'm taking the derivative of a derivative. Okay, times my second, which it looks like is x squared minus x. Okay, plus, now the derivative of the second. Okay, so that's going to be 2x minus 1 times the first, which is f prime of x. Okay, so whew, a lot going on there. All right, and so what I'm going to do, do I want to clean it up? You know what? I think I'm just going to leave it like that. I'm just going to leave it. So p prime of 5. We have e to the 5th times f of 5 plus f prime of 5 times e to the 5th. Okay. Minus f double prime of 5. Okay. Times 5 squared minus 5. Minus, right? We have to distribute this negative. So watch out. That's why that negative in the parentheses is so very important. Okay, minus 2 times 5 minus 1 times f prime of 5. Okay, so there's a lot going on here, and normally I would tell you just stop, you're done. But it has to be all numerical, no functions. So like f of 5, that's a problem, f prime of 5, f double prime of 5, f prime of 5. So we have to go ahead and substitute those out. So e to the 5th times, and I'm going to go to my table. Let's look at 5. What do I want? F of 5? That's 3. 3. So times 3 plus f prime of 5, well, that's 7. Okay, so 7e to the 5th. Minus f double prime of 5, that's 2. That's 2 times 5 squared minus 5. Minus 2 times 5 minus 1. F prime of 5, which again we said was 7. So there's your answer. If this is an FRQ, stop. Do not simplify. Do not simplify. You may or may not make a mistake, and if you make a mistake, you're going to lose the points. So stop. If you don't have to simplify, don't simplify. That being said, what if this is a multiple choice? We want to go ahead and simplify this. So we have 3e to the 5th plus 7e to the 5th. Okay, minus 2 times 25 minus 5, that gives us 20. Minus, what do we got here? 10 take away 1, that's 9 times 7. Oh, going to test me on my 9s. Okay, and then kind of simplifying this gives us 10e to the 5th. That's going to be negative 40. This is going to be negative 63. So we get negative 103, and I got it right. There you go. Okay. Hey, in this video, we talked about the product rule. It is right behind me, right here on the board. And we talked about how to find the derivative of functions analytically and in table form. The next video that I make, we're going to go ahead and talk about how do we find the derivative using the product rule, specifically looking at graphs. Okay, give me a thumbs up, like my stuff, and subscribe for more awesome math videos. Right, Maria?
For sure.
For sure. Peace.